Next, we will be talking about translations. Yesterday, we talked about reflections over vertical horizontal lines and also the line y equals x. Today, we're going to work on translations. A translation, as you know, is another word for a slide. Every point must move the same distance and direction to create the image. Now, something that's important is the vector. The vector tells what distance and direction to move. You've seen a vector that looks like this arrow. It shows where to move point A to become the image of A. In this case, we are moving up 2 and to the right 4. It can also be written in this format. So, a number written like this, it almost looks like a coordinate point, but the difference and defining factor is the arrow on the end, and that will tell you that it's a vector. So, for example, the first number will tell you to shift right. The second number tells you to go up 2. Now, a first number always tells you left or right. The second number always tells you what to do up or down. If the number is positive, you're either moving right or up. If the number is negative, you're moving left or down. So it doesn't really matter if you go right 4 then up 2, or if you go up 2 then right 4, you'll end in the same spot. Let's do an example together. Just like we worked on, make sure when you plot the points you label them and connect them to create the shape. Now this one says, graph each figure and its image along the given vector. So it gives us the 3 points for triangle EFG. I went ahead and plotted those in black, you can see. And then it tells me this vector is 2, 5. The first number tells you whether to move left or right. So this is saying go right 2. I know it's right instead of left because it's positive. And the second number tells you what to do vertically. This one, since it's positive, I know to go up 5. So for each point, I'm going to go to the right 2, and then I'm going to go up 5 to find the image. You repeat the process for every single point. So for point G, I'll go right 2, and then I'll go up 5. Again, it doesn't matter. You could do up 5 first, and then to the right 2, you'll land on the same image. Repeat the process for every single point, then connect the points to draw your image. Now, a tip for you is that you can also add the vector to each point to find the image. So, for example, to find the image of E, I could take -7 plus 2. For my x value, it gives me -5. I'm getting the 2 from the vector. And -1 plus 5, the 5 is also coming from the vector, to get 4 for the y value. So I can double check in that way to see if the image of E was at -5, 4. Remember, another way you can check is visually, does your shape look congruent, the image and the pre-image? Let's do another one together. This one, our vector has some negative values. The first value tells you what to do horizontally. Since it's negative, I know to go left 3. The second number tells you to do what to do vertically. Since it's negative, I know I should go down 4. So for every single point, once I have them plotted, I'll go left 3, and then I'll go down 4. Again, it doesn't matter if you do left or down first, and you repeat the process for every single point. Make sure you're very careful when you count that you're going the same every single time along the vector. Now double check, does it look the same? Yes, it does. Now for this, when we're adding the vector, it's a negative number. So we have to do 3 plus -3. So we get 0 for the x value for the image of J. And then we take the original point 4 and we add -4, the vector. That's where we get 0 for the y value for the image of J. So just to repeat, you can always add the vector to the point to find the image. Alright, if you feel like you need some extra practice with this, you can go ahead and try these practice problems. Here's the correct answer for this one. you have to go left 4, down 1. And here's the correct answer for this one. You need to go right 7, up 1. Just as a note, once you find one of the points, you can always find the other point because we know that the image must be congruent to the pre-image. So for example, segment TS is a vertical line. Since this is just a translation, I know that it's still going to be a vertical line. I can find the length of segment TS by counting how many units apart the points are. In this case, it's 5 units. So I know on the image, the segment will also have a length of 5 units. So once you find one of the points, you should really pretty easily be able to find the other 3 based on the fact that the 2 shapes have to be congruent. Alright, last but not least, I'd like you to try this challenge problem, and what I want you to do is try to see if you can write the translation vector. You want to start on the blue and end on the green. This is very similar to what we did on the activity with the rigid motion, the transformation golf. I want you to see if you can come up with the translation vector this time. Finally, I want you to answer this question. Why is the order of a translation vector important? For example, 2, 7 is not the same as 7, 2. But why is it important even though the order of translating up or down first versus left to right first does not matter? See if you can tell me why is that order for the vector important. Tomorrow we will continue on learning about transformations. Tomorrow we're going to learn about rotations. So I'll see you then. Bye.